This is another version of the HR diagram, and in this one we've actually labelled where we find our stars. So the really weird thing is when you actually plot stars on the HR diagram, they end up in particular clusters. And we end up with this this band going through the centre diagonally, and that's our main sequence stars. So stars that are middle-aged and stable, they exist on this band here. And up in that top right-hand corner, we end up with our giants and our supergiants. And down in the bottom left-hand corner, we end up with our white dwarfs and our smaller stars. So our old stars. So how does this then work? So we can actually plot the life cycle of a star on the HR diagram. So if we have a look and we think about the sun, and it's actually on this diagram, you can see there, it would have moved onto the diagram, onto the HR diagram, from off to the right somewhere as a protostar, and basically it would have got brighter, so its spectral class and temperature would have gone up, and it would have moved across onto the main sequence line there, and then as it runs out of hydrogen, it will actually traverse that instability strip. So there's those two blue lines there. It'll quickly move across and it will become a red giant. When the core of the red giant runs out of stuff to fuse, it's going to basically collapse again and blow off the outer layers as a planetary nebula, and it's going to go down and form a white dwarf down the corner. So we can follow the life cycle of a star on here. Now, what you need to realize here is if you have a look at where the white dwarfs are, and I've said this to you before, they're dull, but they're also hot. So they're actually incredibly hot in the center, like the core's hot, but because they're so tiny, they're not very luminous. We don't see them, they're not very bright, just to do with their size. Whereas a supergiant star, you can see is actually cooler because it's further to the right, but it's much more luminous, and that's just because it's so much bigger. So the position on here is going to tell you stuff about the size, it's going to tell you stuff about the temperature, the color, and where they are in their life cycle, which is really cool. So from this, you really need to be able to identify the main sequence band, and you need to be able to identify where your red giants and your red supergiants go, and then where they go to die down in the white dwarf section. What you will notice on here are these blue supergiants, and they're up in the top left-hand corner. So they're stars that are really bright, and they're also really hot. What's the deal with them? They don't look like they belong anywhere. So these ones are actually really unstable, and we see a lot of them, but that's not because there are lots of them or because they live a long time. We just see lots of them because they're so bright that we notice them. So these ones are basically, they've just moved off the main sequence. They're incredibly hot, they're incredibly bright, and they have short lifespans. So they'll definitely supernova, but they're just our hottest and brightest stars.